When DJI told me they were launching 2 new digital video systems for FPV, I had a lot of questions. How does the image quality of these new systems compare to DJI O3, the best from WalkSnail Avatar, and the latest and greatest GoPros? How does the latency of the new race mode compare to analog or HD0? And how does the VTX output power of these new systems affect the range and penetration that you're going to see? Most importantly, how are we even going to mount these new cameras in our existing FPV frames? This video is going to answer those questions and many more. It's the most detailed product review and testing video I've ever attempted. Please use the timestamps to jump to the sections that interest you most, or sit back, relax and enjoy this deep dive into DJI O4. Hi there everyone and welcome back to the channel. Today's video is going to be a technical deep dive on 2 brand new digital FPV systems from DJI. That's right, we're going to be looking at the O4 Air Unit Pro and the O4 Air Unit, and covering not just the specs and features of these new systems, but also putting them through a battery of tests, comparing them to the previous generation O3 Air Unit, as well as competition from the likes of GoPro and WalkSnail Avatar. These tests are going to include image quality, field of view, including the effect of RockSteady, latency, including the new race mode that's available on O4, and VTX Output Power. It's a huge amount to cover. This is probably the most in-depth product review video I've ever done. And by the end of it, you're going to know everything you need to know about these new systems and whether they're going to be right for your next build. Let's not waste any more time. There's heaps to get through. Let's dive right into it. As you watch this video, don't forget to like, subscribe, and let me know what you think down in the comments. If at any point during the video you'd like to pick up an O4 Pro or O4 Air Unit, there are links down in the video description to where you can get them today, and they are affiliate links, which means that if you use them, it helps support the channel and it won't cost you anything. So please do use those links if you possibly can. Let's start by looking at the physical dimensions and mounting, and head on over to the bench where we can get up close and personal with this new hardware. Alright, so I finally have the DJI O4 Air Unit Pro on the bench, and let's start by just looking at the physical dimensions. I think the easiest way to show this is just to put it side by side with the O3 Air Unit. The new O4 Air Unit VTX is very similar size to the O3 VTX. It's 33.1mm wide by 33.5mm long. It's a little bit shorter than the O3 Air Unit, coming in at just 13mm tall. And if we move to the antennas, you can see that we now have a different antenna layout. So whereas before we had a single antenna, now we have 2 separate antennas. The antenna cables are 50mm long. The rigid part of the antenna is 54mm long, and the diameter of the antenna pole is 3.5mm, which is narrower than the 4mm antenna pole that we got on the O3 Air Unit. If we look at the camera cable, you can see immediately that the O4 Air Unit Pro has a much longer camera cable than what we got on the O3 Air Unit. This camera cable is 130mm from the back of the camera to the VTX, and the cable that's provided to connect to the flight controller is 100mm long, not including the plugs. The O4 Air Unit Pro camera is significantly bigger than the DJI O3 camera. The O4 Air Unit camera is 25mm long by 23mm tall, but it retains the same 20mm width as the DJI O3 camera. Looking now at mountings, and the O4 VTX adopts a very standard mounting pattern. We have M2 threaded holes on the bottom for 20 by 20 and 25.5 by 25.5mm mounting. And on the top of the VTX, we have 4 screws that hold the VTX together, and they are M2 and again 25.5 by 25.5mm spacing. When it comes to the camera, however, we have a totally different mounting pattern. We now have 2 M2 threaded holes that are spaced 16mm apart and 7.5mm back from the rear of the camera. This is a totally new mounting pattern for a camera. We've never seen anything like this before. Let's look now at the DJI O4 Air Unit, and this is a lightweight single board design for smaller quads. The PCB is 30mm by 30mm, and it has 25.5 by 25.5mm mounting, M2. The board is 5mm thick at the USB-C connector, which is the thickest point. The antenna is 50mm long with a 5.5mm diameter rigid section before the actual whip emitter. Similarly, the
camera cable is 50mm long, and the cable to connect to the flight controller is also 50mm long, not including plugs. The camera module is 16.5mm tall by 12.5mm wide by 10.5mm deep to the back of the PCB. DJI also provide this plastic adapter which just kind of clips over the camera module, and that adapts it to be exactly 14mm wide, and it also provides two holes 16mm apart that are M2, but they're not threaded. So DJI actually provide some M2 style, but they're self-tapping screws to go into that plastic, and you can use that to mount it if you want to use these 16mm spaced holes. Alternatively, I think a 3D printed mount for camera this size is probably going to work just as well.
If you're wondering what frames will work with these new O4 cameras, given that they have a totally new camera mounting, then I've got some really good news for you. All existing AOS V5 frames, that is all AOS frames with a metal camera cage, will fully support both the O4 Pro and O4 standard camera using a simple 3D printed adapter, and I'll put a link to that down in the video description. This is a full soft mount that supports gyro flow and RockSteady. It supports ND filters. It perfectly places the camera to provide maximum protection from the camera cage whilst guaranteeing no props in view and no camera cage in view in your FPV feed. It really is an excellent solution. It's both robust and high performance. I'm really proud of it. And yet that's going to be supporting all existing AOS V5 frames with a metal camera cage. As well as the camera mounting, I'm also going to be providing antenna mounts for all AOS frames that will support these new slightly narrower twin antennas.
Let's take a look at the weights, starting with the DJI O4 Air Unit Pro. The camera and VTX come in at 29.6 grams, and if we include both of the stock antennas, that brings the weight up a little bit to 33.8 grams. Looking at the O4 Air Unit, the camera and VTX come in at 8.8 grams. And if you include the antenna, that brings it up to 9.5 grams. And then if you add the plastic camera adapter, that brings it up to 10.2 grams.
If we compare these weights to the previous generation and to competition, we can see that DJI has taken a big step forward here. The O4 Air Unit Pro is about 5 grams lighter than the O3 Air Unit and about 9 grams lighter than the WalkSnail Avatar Moonlight 4K kit. But it's the O4 Air Unit where I think they've made the biggest step forward. That's 16 grams lighter than a Caddx Vista plus a 14mm camera and weighs almost exactly the same as the WalkSnail Avatar Nano Kit, which is the lightest digital VTX with onboard recording that you could get up until this point. And of course, the O4 offers 4K recording, which the Avatar Nano doesn't. This section is going to be all about image quality, and I'm going to start by taking you through the specs of the O4 Air Unit Pro. The camera has a 1/1.3 inch CMOS sensor, and that is a huge sensor. It's much bigger than we got in O3, and it's about twice the sensor area of the GoPro Hero 13 Black. So it is a huge sensor, and that's why DJI have had to move the camera mounting holes to that awkward position. It's because the sensor is so big. In terms of field of view, now this does depend on what mode you have the camera set in and whether you have the electronic image stabilization turned on. But I'll give you the specs because I'm going to take you through the field of view later in the video. The specs from DJI are that FOV is 155 degrees, the equivalent focal length is 12mm, the aperture maximum is f2.8, and the minimum focal distance is 0.6 meters. But you're definitely going to want to watch the FOV section later in the video to see how all the different modes play into that. The ISO range is anywhere from 100 to 25/600. There's an auto and a manual setting. And now we get onto the resolutions, and I think this is the most exciting bit for me. We now have 4K 4:3 aspect ratio, which we never had before, up to 60 frames a second. In addition to that, we have 4K 16:9 at up to 120 frames a second, 2.7K 4:3 up to 60 frames a second, and 2.7K 16:9 up to 120 frames a second. 1080 in both 4:3 and 16:9 aspect ratio up to 120 frames a second. The video format is MP4 and the codec is H.265, and the maximum video bitrate is a massive 130 megabits per second, which is exactly what you need if you're recording 4K 4:3 aspect ratio at 60 frames a second and you want to record really dynamic FPV footage without any compression artifacts. In terms of color, we have a standard normal color mode and also D-Log-M color. So if you want to use a LUT in post and have the maximum flexibility, you can use that D-Log-M color mode to give you that flexibility. In terms of image stabilization, we have RockSteady 3.0, but the camera will also save gyro data alongside the video file, so you can use GyroFlow in post if you'd prefer. Now let's look at some side-by-side comparison footage of the O4A Unit Pro against competition from GoPro, WalkSnow Avatar and DJI O3 and see how they compare. I'm not going to tell you straight away which image is which. Let you make up your own mind, and then I'll put the labels on later. This is the side-by-side image quality comparison for the O4 Pro in daylight. And it's a challenging lighting condition because the sun is low in the sky, but we have some dark areas in the image as well. Everything was shot in 4K 60 standard color profile, so have a look and see which of the cameras you think is doing best in terms of representing the colors, and also which camera is doing best in terms of dynamic range. Now I'm going to zoom in, so we are 1 for 1, pixel for pixel, and you can see how the cameras are each handling the fine detail, particularly in the darker areas of the image, because that's often where detail can be lost. Have a look and see which camera you think is doing best in terms of the fine detail. Now I'm going to show you which camera is which, so you can see if you guessed if you were right, and which one you prefer, and how the O4 Pro is stacking up against its competition here. And this is the image quality comparison for the O4 Pro and its competition in twilight, again shot in 4K 60 standard color profile. So have a look at which camera you think is doing best in terms of capturing the colors of this twilight scene. It's a pretty challenging lighting environment with some brightness in the sky, but everything is quite dark now. And then what I'm going to do is I'm going to zoom the image in so that it's pixel for pixel from the original, and you can have a look at the fine detail that these cameras are able to capture, particularly in this low light level scenario. Have a look at which camera is able to capture the most detail in the shadows. Then once you've made up your mind as to which camera produces the image you prefer, again I'm going to show you which is which. And you can decide for yourself whether you think the O4 Pro is doing better or worse than its competition in this test. Now that you've looked at the side-by-side testing for yourself and decided which camera you prefer, I can give you my thoughts. And I'm not a camera expert by any means, but I have done a fair bit of pixel peeping at these types of side-by-side comparisons. I think overall the DJI O4 Pro wins this test outright. And I'm basing that mainly on the dynamic range in the image and the detail in the shadows. The O4 Pro is able to capture more detail in the darker parts of the image, and that's noticeable in both the daylight and twilight footage. It's doing much better than DJI O3, better than the WalkSnow Moonlight 4K, and critically better than my GoPro Hero 12 Black. So I think that's mainly to do with just the larger sensor in the O4 Pro camera. It's able to gather in much more light, and that helps it provide more detail in those darker parts of the image and cope better with the range of brightness that we see, particularly in that daylight footage. Now we're going to talk about the image quality for the O4 Air unit. And again, I'm going to take you through the specs before we look at the side-by-side testing. The O4 Air unit has a 1/2 inch CMOS sensor, and that is a huge sensor for this type of camera. A typical nano FPV camera would have something like a 1/3.2 inch sensor. The sensor in the O4 Air unit is twice the size of a typical nano FPV sensor. That's going to help it a lot in low light and help it with dynamic range and shadow detail. In terms of field of view, again, it depends what setting the camera is in and whether you're using image stabilization. But DJI specs are that the FOV is 117.6 degrees. That's an equivalent focal length of 14 millimeters. The maximum aperture is f2.8 and the minimum focal distance is 0.6 meters. The ISO is 100 to 6400 in auto mode or 100 to 12800 in manual mode. In terms of video resolutions, a little bit simpler than what we had on the O4 Air Unit Pro. We have 4K in 4:3 aspect ratio up to 60 frames a second. We have 4K 69 up to 60 frames a second. We have 1080p in 4:3 aspect ratio up to 120 frames a second, and 1080p in 16:9 resolution up to 120 frames a second. The video format is MP4 and the codec is H.265, and the maximum video bitrate is 100 megabits per second, so a little bit less than we get with the O4 Air Unit Pro, but still should be plenty for dynamic footage at 4K. The color mode, we just have standard normal color here. There's no D-Log-M on the O4 Air Unit, and we have two FOV settings, a standard and a wide angle, which we're going to look at later in the FOV section of this video. In terms of image stabilization, again, we have RockSteady available on the O4 Air Unit, and that's RockSteady 3.0 Plus. And if you're not using RockSteady, it does output gyro data for use with GyroFlow, so you can do image stabilization in post as well. So now that you know the specs, let's look at the side-by-side image quality testing. This is the side-by-side image quality comparison for the O4 Air Unit in daylight against the WalkSnail Avatar Nano Kit V3 and the Caddx Vista Nebula Pro Nano. Let's start by looking at the colors in this image and the dynamic range, how much detail are each of the cameras able to capture, particularly in the shadows. Now I'm going to zoom the image in so you can get an idea of the fine detail that each of these cameras are able to capture. Have a look at the branches, particularly those in the distance, and decide which of the cameras you think is giving you the best fine detail. Now I'm going to show you which camera is which. So did you guess right? Were you able to pick the O4 Air Unit out? And how do you think it compares against the competition here? This is a side-by-side image quality comparison in twilight for the O4 Air Unit, again against the Avatar Nano Kit V3 and the Vista Nebula Pro Nano. Have a look at the colors and dynamic range initially of the image and see which camera is capturing the most dynamic range and the best colors. Now I'm going to zoom the images in so you can have a look at the fine detail in the branches, particularly the branches in the distance for this lower light setting. Again, were you able to pick out the O4 Air Unit, and how do you think it compares against competition? Now that you've seen the test results side by side and made up your own mind, I can give you my thoughts. And I'm actually more excited about this result than I was for the result for the O4 Air Unit Pro, because normally nano cameras have always been a little bit of a disappointment. When you've moved to that smaller size, you've always given up quite a lot in terms of image quality and detail, particularly detail in the shadows. But the O4 Air Unit really raises the bar on what image quality is achievable down at that kind of 10 gram weight level. I was really impressed with what it was able to deliver, and it certainly was far ahead of the Caddx Vista Nebula Nano and far ahead of the WalkSnail Avatar Nano Kit V3. And that's not even taking into account that you can record in 4K 4:3 aspect ratio 60 frames a second, which you just have not been able to do before with a VTX at this size and weight. In this section, we're going to be looking at the field of view that you get from these camera systems. And it's a bit complicated because it depends on the field of view setting, the aspect ratio, and whether you're using the RockSteady image stabilization. Let's start with the O4 Air Unit Pro and its ultra-wide setting in a 4:3 aspect ratio. This uses the entire sensor because the sensor is a 4:3 aspect ratio sensor, and it gives us the 155-degree diagonal field of view that DJI specify. You can see that if we apply electronic image stabilization, RockSteady, to that, you can see it crops in quite significantly to provide some room for the electronic image stabilization to work. If we then look at the ultra-wide setting in 16:9 aspect ratio, there is no cropping here. We would expect a crop, but there isn't any. Instead, this is a non-linear vertical stretch. So we're still using the full 4:3 aspect ratio sensor, and we are doing a non-linear vertical stretch to squidge all of that image into a 16:9 frame. And this is very similar to the algorithm that GoPro uses for its super view. Again, if we apply electronic image stabilization to this 16:9 ultra-wide frame, it crops it in significantly to allow the EIS to work. Now let's look at the wide setting. In 4:3 wide, we have a small crop all around. And that's exactly as we would expect. This is a narrower field of view. It just crops in on that full sensor. If we then apply RockSteady on the wide setting, we get another additional crop. And what's interesting here is that ultra wide with RockSteady and wide with RockSteady are exactly the same field of view. So if you're in that ultra wide mode, to actually get any benefit from ultra-wide, you have to turn RockSteady off. If you turn it on, you're going to get exactly the same image as you would with the wide field of view with RockSteady on. If we then go to the 16:9 wide setting, this is different again. This is a larger vertical crop on the sensor, and there's no nonlinear stretch here. So unlike with the ultra-wide setting, where 4.3 and 16:9 actually had the same vertical field of view, with the wide setting, we have a different vertical field of view with the 4.3 aspect ratio and the 16:9 aspect ratio. Again, if we apply RockSteady to this, we get a crop in, and this time actually the crop is more than we would get on the ultra-wide setting. So that's just something to be aware of. For some reason, they've decided to crop in more than they need to here for RockSteady. For the normal setting in 4.3, so this is the narrowest field of view, again, this is a larger crop all around on the 4.3 sensor, as we would expect. What's interesting is when we apply RockSteady to this, it actually crops in even more. And this is strange because we shouldn't need any additional crop here to apply image stabilization because we're already cropped in quite a lot, but still the RockSteady setting will apply an additional crop on top of what you ordinarily get, so you'll get an even narrower field of view. If we look at the 16:9 normal setting, again, this is a larger crop all the way around and a larger vertical crop, and there's no nonlinear stretch going on. And the same as before, if we then turn electronic image stabilization on, we get even more cropping in on that 16:9 image over and above what you would get on any of the other modes. So I think this is an interesting choice that DJI have made here to apply an additional crop on even the narrow field of view modes when you turn on RockSteady. And by rights, it shouldn't be necessary because we're already cropped in enough on the sensor that there's plenty of room for image stabilization. I personally would have liked to seen on the wide and maybe the normal fields of view that when you add the RockSteady, it doesn't actually crop anymore. So you get the same field of view with RockSteady on and off. But obviously that's a choice that they've made in their implementation to apply that extra crop. I also compared the field of view of the O4 Pro against the DJI O3 unit, and they have an identical field of view. I also compared it to a GoPro Hero 12 Black, and I found that in the ultra-wide mode with image stabilization off, the O4 Pro has a wider field of view than the Hero 12 Black. But when you turn image stabilization on, then that crops in and then it has a smaller field of view than the Hero 12 Black. As far as I can tell, GoPro has some form of electronic image stabilization on all the time. So I think it's a fairer comparison to compare the RockSteady crop to the GoPro Hero 12 Black rather than the uncropped version. But of course, if you're doing your own image stabilization with gyro flow in post, then maybe that's not going to be such an issue for you. Now let's look at the O4A unit, and here things are a little simpler. In the wide mode and 4:3 aspect ratio, you're getting the widest possible field of view, and that's the 117.6 degrees that DJI specify. If you then set the aspect ratio to 16:9, that is a vertical crop. So it's just reducing the vertical field of view and letterboxing the image to make it 16:9. If we then look at the normal mode, 4.3 normal is just a small crop all the way around on 4.3 wide. So there's not much change in field of view there. If we look at the 16:9 normal mode, you can see that again, that's just a simple vertical crop to letterbox the image, and that's reducing the vertical field of view as a result. Where things get interesting is RockSteady. RockSteady is only available in the normal mode, and if you turn on RockSteady with 4.3 normal, you get quite a significant crop in on all sides, and that gives you the blue dotted line that you can see in this image. If you turn RockSteady on in the 16:9 aspect ratio, you get again a really significant crop that produces this green dotted line, and again it's sort of cropping down, reducing vertical field of view to letterbox the image. With RockSteady on, the field of view on the O4A unit is quite narrow. So I would suggest considering using 4.3 wide and then maybe doing your image stabilization in post if possible. And finally, as a comparison, here's the DJI O4A unit next to the Walk Snail Avatar Nano Kit V3. They're both in 4:3 aspect ratio, and you can see that the Avatar Nano V3 does have a slightly wider field of view. This section is going to be all about video latency, and video latency is really important because it's the time taken from something happening in the drone's field of view to you seeing that thing in your goggles. It's critical for flying fast in close proximity to objects without crashing. We're going to be measuring the glass-to-glass latency for the O4 Pro and O4A units in all their different modes using my latency test setup. So here's a schematic of the test setup, and it works by having two LEDs connected in parallel to a battery and a switch. And this means that when I click the switch, both LEDs turn on and off at exactly the same time. One of the LEDs is placed next to the screen of the DJI Goggles 3, and the other LED is placed shining directly into the camera for the video system. I then have a separate high-speed camera that records at 1000 frames per second pointed at the screen of the goggles, and it can see both the display inside the goggles and also this LED that's just in the corner of the screen here. Then all that's left is to record high-speed footage and turn the LEDs on. I'll see this LED turn on first from the perspective of the high-speed camera because that LED's light is just going to go straight into the lens of the camera and be recorded. The second LED I will see turn on in the screen of the goggles, and the delay between this LED turning on and the high-speed camera seeing this LED turn on in the screen of the goggles gives us the glass-to-glass latency of the system. Here's some example footage from the latency testing. The LED turns on at 0, and now we are counting frames, and at 1000 frames per second, one frame is 1 millisecond. Race mode is the first to display the lit LED in the goggles screen, and actually completes a whole frame before we see any lit LED in either the 4K 60 or 4K 50 frames, which go now. And as you would expect, 4K 30 is the slowest, and that arrives last. In fact, it takes about 94 milliseconds before the 4K 30 completes a whole frame. Now that you've seen how the latency test data has been gathered, let's take a look at the results, starting with the DJI O4 Pro. And there's a new race mode for DJI O4, which promises super low latency, and it delivers. I measured a glass-to-glass latency in race mode, time to first pixel of 15 milliseconds, and then at 100 frames per second in the camera and refreshing in the goggles, the full frame latency is 25 milliseconds. Then if we move to the non-race modes, in general, it doesn't depend what resolution you set, only the frame rate. There is one important exception to this, which might be a bug that I'll cover in a second. At 60 frames per second, regardless of resolution, we get a pipeline latency, time to first bright pixel, of 44 milliseconds, and then it takes an additional 16 milliseconds or so to draw the whole frame for a total latency of 61 milliseconds. And that's to be expected because the goggle screen is refreshing at 60 frames per second and the camera is also running at that rate. In the 50 frames per second modes, the goggles are refreshing at 100 frames per second. So they're drawing the same frame twice, and this is to help reduce the full frame latency. We have a pipeline latency of 40 milliseconds in this mode, time to first bright pixel, and then because the goggles are running at 100 frames per second, it only takes 10 more milliseconds to draw the whole frame for a full frame latency of 50 milliseconds. In the 48 frames per second modes, in every mode apart from 4K, the goggle screen is running at 96 frames per second. So it's twice the camera refresh rate. And again, this helps reduce latency. In the 4K mode, the goggle screen is refreshing at 48 frames per second. So in 4K 48, we have a pipeline of 40 milliseconds and a full frame of 61. But in every other 48 frames per second mode, we have a pipeline of 40 and a full frame of 50 because the goggles are refreshing at 96 frames per second. I think this is a bug, and I would expect DJI to fix this in a future firmware update and make sure that in that 4K 48 mode, the goggles are refreshing at 96 frames per second to give you the lowest latency. In 4K 30, the goggles are refreshing at 60 frames per second. Again, it's drawing the same frame twice. And we have a pipeline latency of 62 milliseconds, time to first bright pixel, and then an additional 16 milliseconds for a full frame. So that's 78 milliseconds total. In low power mode, which you should never be using while you're flying, and if you are flying a wing or using this on a vehicle where you don't have an arming command from the flight controller, make sure to turn off auto low power mode in your goggles. which works correctly now. That will boost the power, drop the latency. In low power mode, the latency is 84 milliseconds pipeline and then 100 milliseconds time to full frame. One final thing to be aware of is that the 120 frames per second modes on DJI O4, both the Pro and the Standard, are only 60 frames per second in the goggles, and they have the same latency as the 60 frames per second modes. So don't use these modes if you want low latency. They're pretty much exclusively just for slow-mo recording. Now let's look at the DJI O4A unit, and things are quite different here compared to the Pro. In race mode, the latency is slightly longer. We're now looking at 22 milliseconds to the first bright pixel and 32 milliseconds time to full frame at 100 frames per second, both the camera and goggles. Outside of race mode, we no longer have the double frame rate effect that we saw with the O4 Pro. So the goggle refresh rate always matches the camera refresh rate, and they're not doing that trick where you double the refresh rate of the goggles to reduce the latency. Again, this might be something that DJI could address in a firmware update to help lower these full frame latencies. Certainly the hardware should be capable of it. At 4K 60, and in fact all the 60 frames per second modes, we have a pipeline latency, time to first bright pixel, of 45 milliseconds and a full frame latency of 61 milliseconds. At 50 frames per second, the pipeline latency is pretty much the same, 44 milliseconds, but the full frame latency is a little longer because of the lower refresh rate, so we're looking at 64 milliseconds for a full frame. And at 30 frames per second, we see the worst latency. Here, both the goggles and the camera are refreshing at 30 frames per second. So we have 61 milliseconds time to first bright pixel and 94 milliseconds time to full frame. And this could really benefit from running the goggles at twice the refresh rate. So run the goggles at 60 frames per second. That would cut the time to full frame down by 16 milliseconds or so and get it down to 78, which would be pretty equivalent to what we saw with the O4 Pro. In low power mode, the goggles and camera are running at 30 frames per second for the O4A unit, and we see a pipeline latency, so time to first bright pixel, of 83 milliseconds and a full frame latency of 116 milliseconds. So I can't stress this enough. Make sure that if you aren't going to have an arming signal going to the air unit to disable low power mode, just make sure you change the setting so that there is no power saving active, to make sure that you get the best latency you can when you're flying on a wing or on a vehicle where you don't have a flight controller. For completeness, here's a comparison chart between the DJI O4 systems and analog, HD0 and WalkSnail Avatar. DJI O4 Pro race mode is definitely significantly faster than any WalkSnail Avatar system, and it is approaching, although it is still not as fast as HD0 and analog. In terms of the non-race mode settings, the latency is pretty much the same as what we had with DJI O3. Now let's talk about VTX Output Power and the video transmission specs for these new O4 systems. And there are some changes compared to O3 that it's well worth being aware of. The first is operating frequency. O4 now adds a new 5.2 GHz operating frequency for pilots in Europe under CE regulation. So if you're in America, you're still going to be using the 5.8 GHz band that we're all familiar with. Same if you're under SRRC regulation. But if you're in Europe under CE regulation, you have the option of 5.8 GHz or 5.2 GHz. And that's important for pilots in Europe because there's actually a higher maximum transmit power allowed on 5.2 GHz compared to 5.8, so that can help with range. In terms of channels and bandwidths, everything is very similar to O3 here. We have 10, 20 and 40 megahertz wide channels, and they use the same frequencies as DJI O3. What's really interesting is that they're now adding a new 60 megahertz wide channel, wider bandwidth for DJI O4, and that allows up to a 60 megabits per second bitrate. And so if you're flying fast over detailed terrain, we all know that digital FPV systems struggle with bitrate under those conditions, and sometimes you can see some kind of smudging and compression artifacts. That is less likely to be an issue if you're using a wider channel, 60 megahertz, with that higher 60 megabits per second bitrate. In terms of the live transmission resolution, the screen in the goggles is always going to be displaying 1080p, no matter what mode you're set to, and you're going to be getting 30, 50, 60 or 100 frames per second depending on what your recording setting is on the air units. In terms of antennas, we have 2 antennas on the O4 Pro and 1 antenna on the standard O4 air unit, and you're probably not going to be worrying too much about channels, bandwidths and operating frequencies because there are just auto modes now on DJI O4 for all of that. So the system will negotiate the channel bandwidth and frequency that's going to work best. But you do still have manual settings if you want to use them. One critical thing to be aware of is when you're in race mode, you are going to have to set your channel and bandwidth manually, and the frequency map is also changed. So in race mode, you're going to have the raceband channels, the standard raceband channels, not the DJI channels that you're used to. So that means you get 8 channels in race mode and a choice of either 20 or 40 megahertz bandwidth. For pilots in Europe who are planning to travel to the US, it is good to know that the ham CFG support unlock for DJI O3 also works on both the O4 Pro and O4 Air unit. So if you want to unlock your device to FCC mode because you're traveling or for any other reason, then you can do it the same as you can with DJI O3, and that will give you higher transmit powers and more channels available.
Before we dive into the VTX power output testing results, I just want to show you the test setup that I'm using to collect the data. I have the VTX in the back of a quad connected to the flight controller for power and data, and each antenna output is connected through a 30 decibel attenuator into these ADL5902 true RMS RF power meters. That converts the RF power into an analog voltage signal, which is read by this Arduino and displayed here on the screen. It's also logged and averaged, so we can see the average RF output power on each antenna for each mode. In terms of cooling, I have a fan pointed at the VTX to keep it cool and stop it overheating, even on the higher VTX output power settings. And while this is by no means a reference grade setup, I do see agreement to within about 1 dBm of published FCC results for previous DJI VTXs. So I'm pretty confident that we're going to get a reasonable measure of the conducted output power from these systems.
Without further ado, let's look at the VTX power output test results for the O4 Pro Air unit. And this is with manual channel, manual power and power fine tuning set to 0. The total conducted output power, which is what we're displaying here, is the sum of the conducted output power across both antennas, and we have all the channels represented from channel 1 all the way up to channel 7, as well as all of the power settings that are available from 25 milliwatts all the way up to 1200 milliwatts. In the low power mode, so when the air unit's just waiting to take off, it transmits anywhere from 1 to 3 milliwatts of output power, and then all of the power settings from 25 milliwatts all the way up to 1200 milliwatts all consistently delivered about half of the setting number in terms of conducted output power. So on the 1200 milliwatt setting, it's delivering a total of 600 milliwatts of conducted output power. And the reason for this is that when DJI specify the 1200 milliwatt number, they are specifying that as an effective isotropic radiated power. That means that they're taking into account antenna gain, and the antennas that they provide with the O4 Pro Air unit have about 3 dB of antenna gain, which means that the conducted output power that we should be expecting is half the effective isotropic radiated power, and so on the 1200 milliwatt setting, we get 600 milliwatts of conducted output power exactly as we would expect. In terms of consistency, the Air unit is quite consistent in output power across all of the channels. Maybe channels 6 and channel 7 are a little bit lower than the others, but certainly from channel 1 up to channel 5, we're getting a very consistent output power. And that variation with frequency is all down to the tuning of the power amplifiers, so it is something that can potentially be improved in firmware. Now let's take a look at the DJI O4 Air unit. As with the O4 Pro, I'm using a manual channel, manual power and power fine tuning set to 0 for this testing, and we're looking at the total conducted output power. But of course now we only have one antenna output, so we're not summing across multiple antennas. In terms of the power settings, we no longer have a 1200 milliwatt setting with the O4 Air unit. That's only available on the Pro. And the conducted output power, in this case, the maximum conducted output power, is around a quarter of the power setting. And the way I understand it is that the O4 standard Air unit has
only one antenna versus the two of the O4 Pro, and the conducted output power for the O4 air unit is the same as the Pro for each power setting, but obviously because we only have one antenna, the total conducted output power is going to be half. The variation in output power across channels is much greater in the O4 air unit in my testing than the O4 Pro, and perhaps this is because DJI have not yet tuned the PAs on the O4 air unit to get a consistent output power across all the frequencies. You can see that we have a big drop in power output on channels 1 and 2 and on channels 6 and 7, with maximum power being delivered across channels 3, 4 and 5. You can also see that the 400 milliwatt setting is pretty much the same as the 700 milliwatt setting on the maximum channels, so 3, 4 and 5. And that again suggests that the PAs haven't been tuned yet. Hopefully they can address this in a firmware update or in the release units to make sure that we get a nice consistent output power across all the channels. Comparing the VTX output power of these new O4 systems against the previous generation, we can see that DJI have taken a step forward here in terms of output power. The O4 air unit is delivering about twice the conducted output power on the channels where it's performing well as the Cadex Vista with the O3 firmware. And all else equal, that's going to give you about 40% more range and penetration. And that of course doesn't take into account any improvements that DJI may have made to the robustness of the link at the same output power. The O4 Pro air unit is delivering about twice the conducted output power of the DJI O3 air unit. And so again, that's going to give you about 40% more range and penetration, not taking into account any improvements that DJI have made to the link at the same output power. If we compare to competition from Walks now, we can see that the O4 air unit is delivering pretty much the same output power, again on the channels where it's performing well, as the Walks Now Avatar Nano V3. And I'm assuming that DJI are going to be able to bring the output power of these 4 channels up to be similar to the middle 3 channels by tuning the power amplifiers. For the O4 Pro air unit, that's delivering pretty much exactly the same output power as the Walks Now Avatar Moonlight 4K kit. And so, again, DJI is on par with competition here. The O4 Pro air unit can't match the output power of the Walks Now Avatar GT, but we have to remember that that is a larger VTX with an inbuilt fan, and so that does give it an advantage in terms of the ability to cool itself and therefore deliver more output power. A couple of final comments on the VTX power output testing. In the firmware that I'm using, which is beta firmware, I was not able to use the 5.2 gigahertz bands, so I couldn't test the output power on those channels. Hopefully that will be available in the release firmware. And also, of course, the power output consistency may change a bit with the release firmware, particularly for the O4 air unit if they tune the PAs. If DJI do make a change to that and let me know, I'll do a follow-up video and link it down below. Now let's talk about compatibility, starting with the O4 Pro. The supported input voltage range is anywhere from 7.4 to 26.4 volts. This means that it's going to support a 3 to 6S battery, down to 2.5 volts per cell on 3S, and up to 4.35 volts per cell on 6S. The supported temperature range for the air unit is anywhere from -10 to 40 degrees C. So if you're flying in higher ambient temperatures than 40 degrees, you might want to consider an extra fan or something to help with cooling. And the onboard storage is 4 gigabytes. Now that's not going to be enough to record much video, especially at 4K. So I think that onboard storage is mainly just used for firmware updates. The micro SD card slot, which is available on the O4 Pro air unit, has a supported size up to 512 gigabytes, and whatever micro SD card you use, you're going to want to make sure it has a U3, A2 and V30 rating so that it's fast enough to absorb the data from the air unit. In terms of the flight controller systems, currently Betaflight 4.3 and higher versions are supported, but I don't know about iNav or anything like that. In terms of the supported DJI goggles and remote controllers that you can use with these air units, you can use the DJI Goggles 3 and the DJI FPV Remote Controller 3. You can use the DJI Goggles N3 and DJI FPV Remote Controller 3, or you can use the DJI Goggles 2 or Integra with the DJI FPV Remote Controller 2. Now, you should be aware that you are not going to have access to race mode if you use the DJI Goggles 2 or Integra. Race mode is only available on the DJI Goggles 3 and N3.
And you're going to get the best latency with the DJI Goggles 3. The N3 is a little bit slower. But those are the goggles and controllers that are supported. I have to say at this point, I would always recommend that you use a separate control link, something like ExpressLRS, rather than relying on the DJI remote controller link, just because if you do lose video, you're also going to lose control link at the same time if you're using the DJI controller, and you won't have anything that you can do about that. If you're using a separate radio control link like ExpressLRS, then you can still flip a return to home switch or something like that and save the quad even if you lose video. The DJI O4 Pro is compatible with ND filters for the DJI Avata 2. And if you're using the AOS O4 camera mount, you're going to want to make sure you use the adapter for ND filters, which moves the camera slightly further forward. Then you can clip the ND filter onto the front of the camera, just like that. For the O4A unit, the supported input voltage range is anywhere from 3.7 up to 13.2 volts. And realistically, this is 2 to 3S lithium battery voltage, down to 2S lithium ion or up to 3S lithium high volt. I've tested this on the bench and the Air unit does brown out at 3.7 volts. So it's not suitable for running on 1S unless you're using a step up voltage regulator. If you want to run on voltages higher than 3S, just run it off the 5 volt regulator on your flight controller and it will draw 1.8 amps while it's recording 4K and transmitting at maximum output power. The supported temperature range is -10 to 40 degrees C, same as the O4 Pro, and while the O4A unit doesn't have a micro SD card slot, it does come with 23 gigabytes of available onboard storage, which is enough for recording a decent amount of 4K video. A good thing that I noticed with the O4A unit is the speed of export of the video is really high. You can access the onboard storage at about 120 megabytes a second over USB, which is faster than I can read off a micro SD on my computer, so that's really nice to see. In terms of the flight controller systems, again, it's Betaflight 4.3 and higher versions that are supported, and the DJI goggles and remote controllers are the same as for the O4 Pro. So the Goggles 3, the Goggles N3, both using the DJI FPV Remote Controller 3, and the DJI Goggles 2 and Goggles Integra with the DJI FPV Remote Controller 2. Just for the avoidance of doubt, the DJI FPV Goggles V2 are not supported on either of these O4 systems. Now that you've seen all of the testing results and I've taken you through all the spec points for these new systems, it's time for me to give you my thoughts and conclusions before I leave you with some more flight footage. Starting with the O4 Pro. I think DJI have taken a huge step forward here. The O4 Pro is better than O3 in every way, and in some ways the improvements in performance are really significant, particularly in image quality. Up until now with O3, DJI have not been able to compete with the image quality from the latest GoPros. And that means that pilots have often flown a GoPro or a naked GoPro alongside the O3 system in order to record the best quality footage. With the O4 Pro, I think the image quality from the O4 Pro is now better than that from the latest GoPros. And that means that you arguably no longer need to run a GoPro to capture the best quality footage. That's going to be a huge benefit, particularly for pilots who are trying to fly under 250 grams, because not having to carry a naked GoPro allows you to fly a larger battery for longer flight time and still stay under that 250 gram weight restriction. The new mountings for the O4 Pro are a bit of a mixed bag. The VTX mounting is definitely better than O3 with the threaded holes for 20x20 and 25x25, but the camera mounting is completely non-standard and will not fit most frames. Fortunately, the AOS V5 frames, that's all AOS frames with a metal camera cage, will fit both the O4 Pro and O4 standard cameras using a 3D printed adapter, and I'll put a link to that adapter down in the video description, as well as a link to a build guide video to show you how to put it all together. In terms of latency, the addition of the new race mode is really interesting. Getting the latency down to 15 milliseconds pipeline and 25 milliseconds to full frame on the O4 Pro is really impressive, and it makes it faster than any of the WalkSnail avatar systems. However, it still doesn't compete with HD0 in terms of latency, so I don't foresee many racers switching from HD0 to the O4 Pro system. I also think that limiting the recording quality to 1080p also makes race mode harder to justify for dynamic freestyle flying, where you might still want to capture in 4K. And if it's at all possible, I'd like to see DJI enable 4K 100 16:9 aspect ratio in race mode. That could make it really useful for dynamic freestyle. For output power, the fact that the output power has doubled compared to DJI O3, and I'm sure there have also been under the hood improvements to the resilience of the wireless link, means that I think range and penetration are going to be significantly improved with the O4 Pro compared to what we had with DJI O3, and that's another feather in its cap that's going to make it just that much better for pilots who are flying in difficult environments like abandoned buildings or dense forest, areas where typically you are worried about losing video signal. Now let's talk about the O4A unit. And while the O4 Pro is a significant upgrade over O3, the O4A unit is a bit of a paradigm shift for smaller 2 and 3S drones. We have never had image quality like this and 4K recording like this at a 10 gram weight. It's hugely impressive what DJI has been able to do here, and it's going to transform the image quality that we can get from these smaller whoops and toothpicks. In terms of mounting, again, the mounting for the VTX is pretty good, 25 by 25. The mounting for the camera is difficult, but on smaller quads, you're probably going to be using a 3D printed mount. So it's probably easier actually for the O4A unit to get a mounting that's going to work than it is for the O4 Pro. In terms of latency, this is an area where I think DJI should really be targeting the O4A unit towards racing and not the O4 Pro. The O4 Pro is too big, too heavy, too expensive for racing. The O4A unit could be a good option, but they need to get that latency down to the same level as the O4 Pro. And I think they can do it because I think the hardware is not too different between the two VTXs. So if they can get the O4A unit down to a 15 millisecond pipeline, 25 millisecond full frame latency, then I think that might tempt some people to try it at least for racing. Also, it's got a 14mm camera, which is what all racers are using. No one's running a 20mm camera who's racing a 5-inch. In terms of output power, the fact that it's double the output power of the Caddx Vista is really great to see. But DJI, you do need to tune the PAs to get those low and high channel powers up to the same level as the middle channels. I'm sure this is just beta firmware, pre-release hardware, all of that stuff. DJI are typically very good on their quality control for their wireless systems, and I'm sure that they're going to sort that out for release, but just sort of make a point of it. DJI, if you are watching, do look into that and make sure that the power output for the O4A unit is consistent across all its channels. Now I'm going to leave you with some flight footage. Don't forget to let me know what you think down in the comments and subscribe to the channel if you haven't already.